Now see here, what is Pascal's law? So, if gravity is neglected, the pressure at every point of liquid in equilibrium of rest is same. See here, for explanation of this, I have taken here the liquid in this container or in this beaker, and this liquid is in equilibrium of rest. And see here, there is a cylinder, imaginary cylinder, and now this cylinder has got curved surfaces and two circular faces 1 and 2. And on this cylinder, liquid is exerting pressure perpendicular to the surfaces. Since this cylinder is also in equilibrium, obviously net force acting on this cylinder is 0. So, the sum of these forces, that is also equal to 0. It means the forces acting at the face 1 and 2 also that will be 0, their vector sum is 0. So, we can write here F1 is equal to F2, because the net force or the vector sum of the forces acting on the cylinder is 0. And here we can take pressure at 1 is P1 and pressure at 2 is P2. So, we can write here P1A is equal to P2A. A is area of cross section. So, now this and this will get cancelled. So, P1 is equal to P2. And see here, this cylinder is assumed in such a way that is a very small cylinder, so that there is no variation in its height, and so that the value of G remains same or that does not change. And now see here, so according to this law, here the pressure at every point of liquid in equilibrium of rest is same.